So in this lecture, we will be looking at some neural word embeddings in code. The first step will be to download some pre-trained word embeddings. So in practice, we typically use word embeddings that have been trained by someone else. The reason why we do this is because these methods tend to use very large data sets. So you don't want to replicate this work if you don't have to. Now, if you just want to learn, then that's a great exercise, which we do in my other courses that focus on these specific algorithms. But for the purpose of this class, that won't be necessary. In addition, note that for newer methods like transformers, there is absolutely no way for you to train those models yourself. Modern methods can cost millions of dollars per training, which doesn't include all the experimentation you need to do to optimize hyperparameters and debug and so forth. So for these methods, you essentially have no choice but to use pre-trained models. For word embeddings, the situation is not so severe, but we typically start with pre-trained vectors anyway. In any case, the next step is to unzip our gzipped file. The next step is to import keyed vectors from GenSim. This class has the necessary API for interacting with the word embeddings we just downloaded. The next step is to call the function loadWordToVec format, passing in the pre-trained word embeddings. The next step is to implement a function called findAnalogies. This function will take in three words, W1, W2, and W3. Their positions in the analogy are as follows. We want to have W1 is to W2 as the result is to W3. So you can see I've represented the result as a question mark in the comments. For example, we might want to do king minus man equals queen minus woman. In this case, the question mark should be queen. If we reorganize the vectors so that we isolate the question mark, we get plus king plus woman minus man. Basically, the important thing to notice is the sign. So what we're going to do is call the function mostSimilar. The inputs to this function are the words which are represented by positive vectors and the words which are represented by negative vectors. As you've seen from above, W1 and W3 should be positive, while W2 should be negative. Note that the result, which I've called R, actually contains multiple words, along with their corresponding scores. Thus, to get the top word only without the score, we index R at 0, 0. The last step is to print out the full analogy so that we can see it in the format we expect. Okay, so the next step is to test our function, starting with our running example. As you can see, we get king minus man equals queen minus woman as expected. Now let's see if this works for cities and countries. As you can see, we get France minus Paris equals England minus London. This makes sense. Now let's test this with another city. So this time we get France minus Paris equals Italy minus Rome. Again, a satisfying result. So you might wonder what would happen if we reverse the order of the country and city. What do we get if we use country minus city instead of city minus country? Okay, so this time we get a poor result. We get Paris minus France equals Lohan minus Italy. As far as I know, this does not make sense. This is our first sign that these vectors are not perfect, although they are pretty good. Now let's try France is to French as what is to English. As expected, we get England. The next step is to try the same kind of analogy, but with different countries. Okay, so this time we get a strange result. We should expect to get China, but instead we get Tibet. Of course, these are closely related countries, so it's not completely incorrect. Furthermore, it's still remarkable that the result is a country and not some random word. The next step is to try the same type of analogy again, but with Italian instead. Okay, so this time we get Italy as expected. The next step is to test this with months of the year. So December is to November as what is to June. Okay, so we get September, which is not quite what we expected, but still not bad as it is a month of the year. Note that for this type of analogy, I've had better success with glove. The next step is to test out cities and states in the United States. So Miami is to Florida as what is to Texas. Okay, so we get Dallas, which is an answer that makes sense. The next step is to test out occupations. So Einstein is to scientist as what is to painter. Now for this, I expected to get something like Picasso or Rembrandt. Personally, I don't know whether or not there is a painter named Jude, but you can feel free to look that up yourself if you're curious. At the very least, it is a name, which makes sense. The next thing we're going to test is pronouns. So man is to woman as what is to she. And the answer is he, as expected. Now let's try man is to woman as what is to aunt. And the answer is uncle, as expected. Now let's try man is to woman as what is to sister. The answer is brother, as expected. Now let's try man is to woman as what is to wife. And the answer is son. For this, I would have expected to get husband, but again, remember that these vectors are not perfect. Note that it still may be the case that husband is in the list of returned results. It's just not the top result. Now let's try man is to woman as actor is to actress. So the result is actor, as expected. Now let's try man is to woman as father is to mother. And again, we get father as expected. Now let's try nephew is to niece as uncle is to aunt. And again, we get uncle as expected. Okay, so recall that what we've done is mapped words to vectors. We've so far looked at analogies, but an even simpler question is to ask, given a word, what are the most similar words? To do this, we're going to write a function called nearest neighbors that takes in only one word. In fact, this function is much simpler than before because we only have to specify the positive argument. Once we get the result, we're simply going to loop through them and print out the matching words. Okay, so let's look at the nearest neighbors for king. So as you can see, we get kings, queen, monarch, crown prince, prince, sultan, and so forth. So these all seem to make sense. Now let's try France. So we get Spain, French, Germany, Europe, Italy, and so forth. This all makes sense, since they are countries, except French, which is not a country but still makes sense, and Europe, which is a continent. But notice that all these countries are in Europe. Now let's try Einstein. So in this case, we get some pretty weird results. Most of these are names, which makes sense. Albert is somehow in third place, which is odd. And somehow LMFAO is in second place. Perhaps this has to do with the fact that people often use the term Einstein sarcastically. Now let's look at the nearest neighbors for woman. In this case, we get man, girl, teenager, and so on. So these mostly make sense. Now let's try nephew. So this time we get son, uncle, brother, grandson, cousin, and so forth. So these all make sense. Now let's try February, which is a month of the year. Okay, so as you can see, most of the other matches are months, which makes sense. So now that you know how word vectors work, it's time to do an exercise. We've just looked at how to analyze word-to-vec vectors. This was relatively easy because we had the GenSim library to do most of the work. However, note that this work is not really that difficult once you have the vectors. For this exercise, you're going to download glove vectors, which gives you the actual vectors stored as text, instead of a binary file like Google's Word2Vec. This file is a very simple format, which you should be able to figure out. Once you've downloaded the glove vectors, you should write the code to implement find analogies and nearest neighbors to work exactly the same way as they did in this notebook. Your goal is to check whether or not glove vectors are better than Word2Vecs. Good luck, and I'll see you in the next lecture.